Hi students, welcome to Math4U. Today we are going to discuss about the properties of rational numbers from grade 8. Let us see what are rational numbers. So rational numbers are numbers that can be written in the form of p by q, where p and q are integers and q not equal to 0. So this you have already learned in grade 7, so I'm not going into detail, but still I'm going to give you an example here. Let us see -3. Whether we can write this -3 in the form of rational numbers or not. Yes, very good. We can represent it in the form of rational numbers like this. So -3 means that is -3 by 1. So now this is of the form p by q and where q not equal to 0. Here the denominator is 1. So let us go ahead with the properties of rational numbers. So first, closure property. So here I'm taking two rational numbers like a by b and c by d. So when it comes to addition, if rational numbers are closed under addition, we can say that a by b plus c by d will be equal to another rational number. So let us check whether this is satisfying or not with an example. So example 1, I'm taking two rational numbers here, 1 by 3 and 3 by 4. So 1 by 3 plus 3 by 4. When we add these two together, we have to get another rational number, right? So let us check that. You know how to add this, you have learned in grade 7. So I'm not going to explain it in detail. So you have to take the LCM of 3 and 4, that is 12, and you will get the numerator as 4 plus 9. So let us see what we are getting, 13 by 12. So you got a rational number here. It is of the form p by q, right? So let us conclude with one more example. So I'm going to take here -2 by 3 and another number as 4 by 5. And let us add these numbers together to check whether we are getting another rational number. So here you can see 3 and 5 as the denominator and we got the LCM as 15. So the numerator will be -10 plus 12 and you got the answer as 2 by 15. So this is also all of the form p by q. So we can conclude here rational numbers are closed under addition, right? Rational numbers are closed under addition. So let us move with subtraction and check whether we are getting another rational number when we subtract two rational numbers. So here, if it satisfies what we have to get, a by b minus c by d should be equal to another rational number. So let us see whether we are getting a rational number with an example. So example 1, let us see -5 by 7 and 2 by 3 I'm taking here and I'm subtracting these two rational numbers. So as we done in the previous case, we have to take the LCM of 7 and 3, that is 21, and the numerator we will get it as -15, -14. So what will be the answer? Is -29 by 21. Here we got it of the form p by q. So it is a rational number. And let us see one more example. So I'm going to take here 5 by 8 and 4 by 5 and subtracting these two, and let us see whether we are getting another rational number. So we will get the LCM here as 40 and we have to check the further numerator. So the numerator will be 25 minus 32. So we got it as -7 by 40. Yes, here also we got it of the form p by q. That means when two rational numbers are subtracting, we get another rational number. So we can say that rational numbers are closed under subtraction, right? We concluded it like rational numbers are closed under subtraction. Is it clear? Yes. So let us move on to next as multiplication. So now we are going to check whether these rational numbers are closed under multiplication. So here, as we have seen before, we have to get A by B into C by D is equal to another rational number. Then only we can conclude that these rational numbers are closed with under multiplication. Yeah. So let us see with an example this one. So I'm taking an example of negative 3 by 7 multiplied with 5 by 14. So you can see here we cannot cancel anything. So we are going to multiply the numerator, that is negative 15, and with the denominator you will get as 98. So here it's of the form P by Q. You can check it and see. And we are going to see another one more example on this to conclude. Okay. So I'm taking 1 by 2 and 5 by 7. So I'm multiplying 1 by 2 and 5 by 7. You can see here the numerator will be 5 and the denominator will be 14. And this is also of the form P by Q. Yes. So what can we conclude here? Rational numbers are closed under multiplication. Okay. So rational numbers are also closed under multiplication. So let us go ahead with the division now and see whether division is closed. Division is satisfying this relation. So division, we are going ahead with same procedure, A by B divided by C by D. You have to check whether we are getting it as a rational number. So let me take another example. Example 1, that is with negative 5 by 3 and 2 by 5. Okay, so I took two rational numbers and dividing it. So how to divide two rational numbers or two fractions also you have learned. Same procedure. You have to take the reciprocal of the second number and multiply with the first. So here you can see you will get it as negative 25 by 6. Okay, so this one you got it as a rational number. Okay, so let me ask you one more thing. If a rational number is divided with 0, what will be the answer? You have already learned that if it comes in the denominator, dividing with 0, that is not defined. So in general, I am taking A by B divided by 0 is not defined. So we can conclude here, right? Like rational numbers are not closed under division. Why? Rational numbers are not closed under division. Why it is not closed under division? Because this is the reason. When we divide a rational number with 0, we can say that it is not defined. You have already learned with the natural numbers and all, right? I hope it is very much clear. So as a conclusion, we can say that addition, subtraction, and multiplication is satisfying, right? That means rational numbers are closed under addition, subtraction, and multiplication, and it is not closed under division. I hope it is very much clear. Thank you.